Hello, everybody. I'm Minoru Uehara, Toyo University, Japan. I talk about programming learning by creating problems. Well, this is outline of my talk. First, I talk about background and objectives. Next, I introduce several related works. Next, I explain the design and usage of JELL. JELL consists of 5 subsystems: JAM, JELL, JAZZ, Jolt, JQuest. We explain them in detail. Next, I show evaluations. Finally, I conclude. Here, I talk about backgrounds and objective. We have 3 backgrounds. Well, in 2020, distance learning increased in Japan because of COVID-19 pandemic. Here, I'd like to say e-learning strikes back. Of course, this comes from the Empire Strikes Back in Star Wars series. We must teach by e-learning. It's a very important point. Many corporations offer e-learning services. However, universities doesn't offer many e-learning services. This is because face-to-face lessons are overrated in Japan. Therefore, many teachers choose to live streaming their lessons. However, video on demand is useful for students because they repeat watching. We have developed a self-study tool combined with on-demand video. Recently, STEM education is important. STEM means science, technology, engineering, mathematics. We have SDGs, Sustainable Development Goals. SDGs consist of 70 goals. Especially, we focus on Goal 9, Industry, Innovation and Infrastructure. In order to continue innovations, information technology is very important and necessary. Therefore, IT engineers are important. In order to cultivate IT engineers, we should teach programming because programming is very important to develop innovative services. In programming learning, active learning is effective if students actively and interactively work on the subject. In cooperative learning, there are many methods. However, regardless of the methods, students learn by teaching each other. So mutual teaching is important. One of mutual teaching methods is creating problems. Students modify an existing problem and create new similar problem. In this way, students understand the concept of programming. Now we show our objective. We develop self-study tool of programming for mutual teaching. Here, we introduce several related works. First, this study is related to active learning. Collaborative learning and cooperative learning is very similar. They are effective in active learning. There are many learning methods in such a field. One of them is learning by teaching, which is proposed by Sutter Stallhans. One of the effective methods of learning by teaching is creating problems. There are many case studies. Here we introduced two cases. Yuki Hirai et al. Developed a question posing based collaborative learning support system named Jolt. They use it in basic computer system class. They prepare BBS for asynchronous communication among students. Masanori Takagi et al. Developed a collaborative web-based training system enabling students to create quizzes and to review them interactively. It is named Collab Test. They use it in computer network class. They considered similarity of problems using TF-IDF. This is an advantage. However, these systems cannot apply to programming. So, it is difficult to apply conventional system to our class. We think the nearest system is programming contest system, such as online judges. There are many online judge systems, such as Topcoder. Of course, they are more complex than our system. However, the principle is simple. In such systems, a code is tested by the unit test method. We employ the same way to check whether an answer is correct or not. Now, we propose JavaScript e-learning laboratory called JELL for short. JELL consists of 5 components: Jam, JDE, Jazz, Jolt, and JQuest. Jam is JELL Account Manager, which is a web application that manages JELL user accounts. JDE is JavaScript Development Environment, which is a single-page application that edits JavaScript sources. Jazz is JavaScript Quizzes, which is a drill system for multiple-choice questions. Jolt is JavaScript Online Test, which is a drill system for writing questions. JQuest is JavaScript Questions, which support exercises that create questions. First, we introduce Jam. Jam is JELL Account Manager. Jam provides functions of authentication and authorization. Jam realizes role-based authorization. There are two roles in Jazz: general users and administrators. General users are students. Administrators are teachers. Next, we introduce JDE. This is a JDE screen. JDE consists of 4 components: buttons, code, output, and console. There are 5 primary buttons and 9 secondary buttons. The secondary buttons support to input special characters and JavaScript syntax efficiently in smartphones. In this way, JDE is designed for smartphone, and no server is required at runtime because JDE is a single-page application. This slide shows code execution mechanism. JELL creates a function object when the run button is pressed. The code is passed as a parameter when a function is created. The console object is a virtual console. It is given as an argument when the function is called. The object is the return value. Next, we introduce JAZZ. JAZZ is JavaScript Quizzes, which is a Dory system for multiple choice questions. The left image is administrator's screen. JAZZ Manager's menu is hidden from general users. Teachers can create problems, and students can solve them. For example, there are 4 quizzes in this case. When you select Q1, you will see the right page. This page is written in English because it is a real question used in the class. In JAZZ, the number of choices is fixed to 4. A student chooses an answer from them and press the Submit button to submit. Next, we introduce Jolt. Jolt is JavaScript Online Test, which is a Dory system for writing questions. This is like an online judge system usually used for programming contests. Jolt uses multiple test cases to make the decision. A test case has input, output, preamble, and postamble. The code body is sandwiched between preamble and postamble. Jolt gives input to the test code, executes it, and compares the result with the output. A teacher creates multiple test cases in a question. Next, we introduce JQuest. JQuest is JavaScript questions, which supports exercises that create questions. First, students create questions. The left figure shows the list of questions. Students must create 3 questions. Q1 and Q2 are multiple choice questions. Q3 is writing questions. The left figure shows editing Q1. Next, students test the created questions. The left figure shows the list of questions. The right figure shows that the student answers question 1. Students confirm that questions are correct. Now, all questions are created, so students publish their questions. As its result, it is able to edit questions and allow to solve them if assigned. Here, a teacher assigns the examiners and examinees. The top box shows all students. If the open button pressed, the right list shows the students who published questions. If the right arrow button pressed, select students are shown in the left side. A teacher selects students and assigns them to each other. Finally, he confirms the examiners and examinees. Then save the assignment. Once the examiners and examinees are assigned, they can solve each other. An examinee must answer questions of 2 examiners. Therefore, total questions are 6. An examinee should finish and submit finally. A teacher confirms that all students finished to solve. A student who the examinees answered can make a report. Finally, students report the reviews. Here, we summarize the flow of JQuest. There are two synchronization processes in this flow. These are problems. Here we discuss on evaluations. As a result, the distance learning is successful because the student's satisfaction increases. However, we do not probe causal relationship. There are too many factors to analyze. This is a future work. We can hold the class without troubles. Students can apply to JELL even if all menu is written in English. However, there are two synchronization processes in JQuest. The synchronization period is long and delay is large, so many students must wait for each other. In order to solve this issue, we will assign the questions of the previous year to students of the year. Now we summarize the conclusions. We have designed and implemented the JELL. JELL, especially JQuest, realizes learning by teaching, and many students satisfy the course using JELL. These are many future works. The code editor used in Jolt and JQuest is not convenient, so WeDirect2Jelly is available for them. JELL allows students to create the same questions, so we'd like to check the similarity of the created questions. We'd like to reuse the created questions for two purposes. First, we'd like to increase the number of questions that students can solve. Second, we'd like to reduce the synchronization period. The reuse of questions is suitable for these purposes. Thank you for your attention.